We're going to talk about the history of early atomic theory and start way back in 400 BC with a philosopher by the name of Democritus. And he imagined a loaf of bread, and if you cut the loaf of bread in half, you get two halves. Well, what if you take each of those halves and cut them in half, and then take a piece and cut it in half, and another piece and cut it in half? Are you ever going to get to a point where you can't cut it in half anymore? And Democritus said, yes, you would get to the smallest particle that there is, and he imagined that you would not be able to cut this particle, and so he called it atomos, meaning not cut. 100 years later, Aristotle came out and said that all matter is made up of fire, air, earth, and water, and his ideas persisted for 2,000 years. Nobody thought to question it or test it out. This was what all matter was made up of. Sir Isaac Newton and Robert Boyle in the 1800s, they even didn't do experiments. They still were just thinking about how science might be, but what not verifying their ideas. And they came up with the idea of that elements were made up of corpuscles. Who knows what those are? That's what they described it as. So, for example, if you had the element gold and the element copper, they would each have different numbers of corpuscles, and so therefore they would be different elements. That was their idea, and it's totally false. And again, none of these people uh, they didn't do experiments to test their ideas. So along came Lavoisier around 1800 and Proust, and remember they did very, very careful experiments. So these early philosophers, because they didn't test their experiments, it didn't really carry them through to discovering anything new. But Dalton, he did careful experiments with his data. He was the one that came up with the law of multiple proportions, and he involved Lavoisier's ideas and also Proust with the law of conservation of mass and also the law of definite proportions. And Dalton put to paper his atomic theory, and we pretty much follow his atomic theory today. So his ideas were good. This is what he said. He said, number one, atoms are the smallest bits of matter. Number two, atoms of the same element are identical. Number three, atoms of different elements are not alike. Number four, atoms combine in simple ratios to form compounds. So that's your law of definite proportions, law of multiple proportions. Number five, atoms cannot be divided or split, and atoms are not created or destroyed in a chemical reaction. So we do use his atomic theory today with two exceptions. Which two did Dalton get wrong? Stop the video and see if you can figure out what we need to change. Okay, we're back. What we needed to change were number two, atoms of the same element are identical. We have discovered isotopes. And in isotopes, we can have atoms of the same element, but some might be a little bit heavier than others because they have more neutrons. And so these are called isotopes, and we are going to be talking about this in a goal later on. The other thing that had to be changed was that atoms can be split. So later on, we found subatomic particles. We found electrons, protons, and neutrons. And so these subatomic particles we know form the atom today. So if we were to add isotopes to his theory and also know that we can split an atom and find those subatomic particles, then this is a very good atomic theory. And so here's just another slide that just shows some examples of isotopes. So for example, we can have carbon 12 and we can have carbon 14. They're both carbon, it's just that carbon 14 is just a little bit heavier. And then again, here are those subatomic particles.